So hello everybody, I am Sebastian. I'm a rising junior at Gun High School right here. And for my starter project, I chose the Minty Boost Kit, which is basically a small phone charger that runs off of 2 AA batteries. For my main project, I have the self-lacing shoe. And I chose this project because I thought it was just a really cool concept that was taken straight out of the movie, Back to the Future 2. I'm sure some of you guys have heard about it. And just the idea of building a self-lacing shoe got me really excited. And I think at the end of the day, that's what it's all about. If you're not excited about what you're building, then the entire process is going to be a lot less enjoyable. So the way this works is there's a little force sensor inside the shoe here. So once you press that down, it's constantly looking for a value of at least 1. If it doesn't read a value, nothing else on the shoe will work. So once you press the force sensor, it will be with your foot, but for this sake I'm using my hand. You press the force sensor, then you have 2 buttons back here, the green and the red. The green button will tighten the shoe as such, and then the red one will proceed to loosen against the big foot out. So basically, the main problem I encountered during the entire construction of the shoe was definitely everything that had to do with coding. Coming into this camp, I had no experience with coding whatsoever, and so any mechanical issues that I faced, I felt like it didn't take too much to get over them. I could always figure those out with a little bit more ease. But when I hit a wall with coding and everything that had to do with electronics, I felt like it was a lot more difficult to get over. In the end, it was just a long process of trial and error, constantly trying all these different functions, most of them failing, but then eventually getting to my state machine, which is what I use now, to get everything working together. The main modification I want to add on my shoe is a couple of spools here on the side of the servos. Because as of right now, when you tighten the shoe, it'll only tighten as far as 180 degrees. Any more than that, it'll just be kind of going in circles. But if you add a spool here on the sides, it can tighten them a lot more, and it can overall, I think, achieve a much more pleasing visual and also a tighter shoe. That modification, again, wouldn't take too long, so I think another modification that would be really cool to add would be some kind of remote control. Instead of having to bend over and touch your shoe to tighten it or loosen it, you could just have a remote control on your fingers with the buttons, and you could tighten it from right up here. Overall, I really enjoyed my time here at Blue Stamp. I learned a lot of really cool skills: dremeling, coding, soldering. I think these are all really cool skills that I can definitely apply later on in life to other cool projects too. But I learned something that I think is a lot more valuable than all that. I learned a lot more about what it means to be an engineer. People don't realize how much documentation matters and public speaking in engineering. When people think engineers, they just think, building things, math, all that. But Blue Stamp really emphasized on how important documentation was. So they had us build our own websites and document our entire process with milestone videos. And then public speaking, every day at lunch, we'd have a guest speaker, or sometimes even our own instructors come in and talk about their field of interest or their field of study. And that really impacted me, I'm sure, my peers as well, how important public speaking can be. It can really separate, the good engineers from the great ones, you could say. I'm definitely gonna miss coming into work on my shoe every day, being surrounded by amazing people, instructors, Sky, Eduardo, Rich, and Asher. Couldn't forget Asher. All amazing people, and I want to thank you guys. And thank you.
You mentioned you use a state machine. Could you explain how that works?
Of course. So basically, what a state machine is, in my state machine, I have 4 different states. In the first 2 states, essentially nothing is happening, but the way to get from each state to another one is, for example, to get from state 1 to state 2, it's just looking for the force sensor to be pressed. Once it is in state 2 and the force sensor is being pressed and being held, in state 2 it's looking for 1 to 2 buttons to be pressed. Hitting the green button will send you to state 4, which is a tightening phase, and then hitting the red button will send you to phase 3, or state 3, which is a loosening phase. So it's just kind of a bunch of different states of being that you can navigate through what they're called inputs, which are pressing the force and pressing the buttons.
So how sensitive is your sensor? Is it 1 pound with a treatment or
Yeah, if you were to pull up a serial monitor on the coding on the Arduino, I set it to just being greater than 1. I played around with it a lot. I had it greater than 100 at first or greater than 75, but I thought that just the slightest bit of force on it should be enough. So I set it to 1.
Okay, how quickly this signal is sent?
Instantly.
After you press down, what's the general time? It should be very, very late.
I didn't use a delay function for mine, so it just goes instantly. I considered using a delay function at first and a millis function, which is more of a timing function, but
You could think about it in real life, if somebody hit your toes, and then you untie your shoes, and then come back, you have constant tight motion.
Right, so it only activates when the buttons are pressed. So at first, what I wanted to do was not even have the buttons and just have them be tied when the force sensor is pressed, and then the timing function would allow it to stop tying after 2 seconds or whatever it might be. But I then opted for the button so you can physically control when to move and when you're not supposed to move.
What kind of motor did you use, and why did you pick that?
These are just continuous rotation servo motors. I chose them because I think I have a lot more control over them as opposed to other servo motors where they only spin 180. Because this way, as I said before, the modification that I want to add to spool, they can keep spinning. And I think I need as much power in a DC motor as we're going to use for this project. So I think it's a good between.
How was it like creating all the code by yourself? Like was that experience from coding?
It was a very frustrating, long, just constant, as I said, trial and error kind of thing. I kept getting suggestions of what I should do, and none of them ever worked out. So, finally coming across the state machine and getting that to work was very gratifying. Very totally good.
All right. Thanks.